This will be a series of videos for the problems out of Evans Chapter 5, Probability Distributions and Data Modeling. Here we have question 1. Lauren drinks a variety of soft drinks. Over the past month, she has had 15 Diet Colas, 4 cans lemonade, 6 cans root beer in no particular order or pattern. Given this history, what is the probability that her next drink will be a Diet Cola, lemonade, or root beer? What definition of probability did you use to answer this question? Well, let's answer B first so we know where to go with this. Basically, there's 3 definitions of these types of probability functions or problems. The first type is classical definition, and that means that you have a complete understanding of all the outputs of a system. It's quite well defined. There's no ambiguity about outputs. And an example of that would be when you're rolling dice. So that falls under the first definition of classical. So what we're looking at here doesn't really have that, although we do say that it's limited to 3 different kinds of drinks. It's not really that predictive. We don't have a complete system definition where you know the states, all the states that can come create outputs as you go along. The second approach is called the relative frequency definition, and that's based on empirical data, and that's what we have here. Here we have empirical data. We're actually just taking a reading of what happens. We're watching Lauren as she drinks, or she's sending in a report here about whatever she drinks. I guess that's some part of a study, let's call it, right? But just to be complete, the third definition is what we call subjective definition, where actually multiple observers can actually come up with a different system definition, and therefore a different way of approaching statistics. And that would be like sports handicapping, looking at who's going to win any sports outcome like the World Series, and the Dow Jones Industrial Average. There's people that have certain opinions that what goes into the inputs that go into creating an output, and at what strengths they have influence over the output. Perennial questions, if you will. So again, this is the second version of this where we're using empirical data. So very quickly, what we're going to do is, and we did this one in class, I'm not going to put a lot of extra words in here because the problem's sitting right here. We know that she's had a total of 15 Diet Colas, and she's had 4 lemonades, and she's had 6 root beers. So we'll sum them up really quickly. See what our total population for this set is. Okay, so the probability of the outcome of any one of these, we can take a look at this, the relative frequency of these. That's what we're looking at. That's going to be equal to the number of this Diet Cola over the total count of all samples that we took, of all tests that we did. Okay. Okay, so we'll make, I'm sorry here, we have to do that one more time. Let me grab that and we'll make that an absolute. The denominator is an absolute here. We don't want an absolute address, that is. We don't want that to change. That's just an F4. So we just calculated the relative distribution probabilities of each of these. And if we sum these up, what we'll do is a nice little format. We'll be at least kind to ourselves that way. And we'll take a look at putting these in terms of, well, let's use percentage here. And we really don't need the 2 places, but we'll leave it there anyway, okay? So 60%, 16 and 24. If we sum those up again, you'll have 100%, just as a check. Let's just make sure that we have that going for us, that everything's checking out here. And what you might want to do is just put like a little underline there, and these are our totals. Okay, the most minimal of all formatting there. So given this history, what is the probability that her next drink will be a Diet Cola? Well, that's how we get these. There's a 60% chance she's going to pick a Diet Cola. Again, this is assuming that there's no relationship about when she did these. It's not as though she took 15 Diet Colas and got tired of them, then took 4 lemonades and got tired of those, and then said, I'm going to go on to root beer. We're treating this as total random. So that's a major point with these kinds of studies, and you have to keep thinking about that. Is there a specific pattern that's been set up here? Is a good way to think about more elaborate problems. But as being that's problem 1 in the beginning of the chapter, we can assume it's fairly simple. But always be on the lookout for things that you should be noticing about the data here, about where you would take it in other kinds of studies that you might do on this, or impart any other kind of influences, like she got tired of diet colas and moved on to lemonades and then to root beers. Okay, so then the probability would be different. We're treating this as totally random. That's it for this problem. We'll move on to the next one.